In this example, we're going to talk about references in C++. In some of the other videos, you've probably seen me use references, and we'll go through some of the different ways you can use references to make your C++ code a little cleaner and easier to understand. I have this file, and I wrote this display method that we're going to use in a moment. And you'll notice it takes a string, an integer, a string, an integer, a string, and then an integer reference. And the point of that is that just lets me print out the different values so that we can see how they change as we move through the program. One thing you'll notice about the reference, though, is unlike a pointer, if we have a reference parameter, we can treat that parameter as just a variable in our code. We don't have to dereference it and keep track of all that. So that's one of the big advantages of references. So we'll use x and y and num1 and num2 as sort of pairs of numbers that will deal with references. So let's make a reference, and we'll set that equal to x. So this is a reference variable. And if I try to do this, here's a second reference. Let's just compile this and see what happens. So you'll notice we get this error on ref2. It's declared as a reference, but it's not initialized. A reference has to be initialized. So we'll comment that out and we'll note that references must be initialized. And let's go ahead and make a num reference too. So there's another num reference. So let's print all these variables that we've done and the references as well. And we'll use display. So our first variable is x, so its name is x, and then there's the variable, second one is y, and then we'll do the ref, and we'll do the same thing for num. And let's compile and run this and see if we're happy with how it prints this out. Okay, so you can see that here x is 10, y is 10, and ref is 10 because x is equal to y to 10, y is equal to x, and then the ref is equal to x. And then for num1 is 10, num2 is 20, numRef is equal to num, so it's a reference to the num variable. So let's see what happens when we set x equals to 20. So here x will be 20, and then let's display x. And if you look at this now that x is 20, y is still 10 because we initialized the variable y with the value of x at that time. But now that x has changed, y doesn't change, it's its own variable. And then the ref, that's a reference to x. So when x changes, y changes. Let's do something similar, but instead of setting x equal to 20, let's set ref equal to 30. So we compile and run. And now notice x is 30. So if we set ref or x, that changes x and ref because that's what they're equal to. Now, one thing I think I should do here before we start is I don't want these strings to change in my code. So I'm going to make those const references. It's always good practice if you know you're not going to change a reference, make sure that it's a const. And this is also going to be a const reference. A and B, I don't need to specify that they're constants because they're passed by value. And so nothing that gets done in the function will affect those. But for the references, it certainly could. And also for these strings. So I think that should work. Okay, so now let's go ahead and write another function that uses a reference. And we'll call this myfunc. and we have a parameter. And what we're going to do is we're going to say that parm is equal to parm times 2. So we're actually changing this. Now this is a reference, so that means we're actually passing by reference, meaning we can change this. That's going to change the actual value or the actual variable that gets passed as a parameter, as an actual parameter. It looks like 1, 2, 3, 4. Let me fix my indents here real quick, just so I'm consistent. Okay, so everything has 4 spaces of indentation. So back to calling my func x, and then let's display this. And so you'll notice it's multiplied x by 60, and so of course reference is also 60. Now what happens if instead of x, we pass in ref? So same as above, except now we're passing ref to that function. There's no problems because ref is a reference, and that's the type. And notice we multiply x by 120 again because reference is an alias of x. Okay, so now let's set ref equal to y. So notice now everything's 10 again. Now y was already 10, but now x and ref are 10. Now why is that? Well, it's because this says set the variable that ref is an alias to the value of y. But now reference is not pointing to y, and we can show that by calling myfunc on ref again, and we'll see the variable that gets modified is x and ref, but y is left alone. So when you do an assignment of a reference, be careful there. That can be confusing. Okay, so let's go ahead and with num and so forth, let's move that down here because we're going to work with those now. So we'll skip a line of our output. And we'll set numref equal to 15. And I guess we should say what we're doing as well. And let's print that out and see. Okay, I think that's what I wanted to do. Okay, so here we have our original values for num. Remember, numref is a reference of num1. So if I set numref to 15, that changes num1. So now let's see an example of a function that returns a reference. So our function is going to return an int reference. So let's just say reference to x. Since we're returning a non-constant reference, we don't want to have the parameters be constant references. So if x is less than or equal to y, we're going to return x. Otherwise, we'll return y. There we go. So a simple function, but notice we're not just returning the value that's smaller, we're returning a reference to what's smaller. There's a lot we can do with this, and you can imagine we could create a new reference if we wanted that said, hey, here's a reference. Now we have a reference to the smaller the parameters. But keep in mind, which is smaller actually returns a reference. So if I do this, that's actually an L value. It's a value that I can use. So if I get the return value here is going to be a reference to the smaller of num1 and num2, and I can make that number equal to 0. So now if I display that number, or actually let's even do this. Let's make that a big number, and it's going to print those values out. And let's see what happens. So whichever is smaller, we're going to make it 100, and that should make it bigger than the other value, right? So num1 is smaller than num2, and notice that return value was a reference to num1, so when I assigned it 100, now that's much bigger. So then the smaller is now which is smaller, num1, num2. What this is saying is there's a reference to the smaller one, just use it, but I'm not actually making any changes. So I could certainly make a new reference to say, hey, whichever one of these is smaller, give me a reference. I'm going to do a bunch of work with it later. That's fine. Here, all I was going to do is whichever one's smaller, I'm going to make it to be 100, and that actually modifies that value. And that's all I want to do, so fine. In fact, I could even have a which is larger, and I could say set which is smaller to which is larger plus 1. So that's also another possibility. So there's a lot you can do with this technique since you're returning an actual reference, which is an L value that you can then do things with. So if we run our code, notice now the smaller number is now 20. Okay, so that's a couple things you could do with references in general, and they can help you write code that's a little bit clearer, a little bit cleaner, and in a lot of cases safer than if you're using pointers.